Limit as x goes to 1 of the sine of 5x minus 5 over x minus 1. The first thing we're going to do is try plugging a 1 in for each of the x's. So we'll have the sine of 5 times 1 minus 5 divided by 1 minus 1. So we have the sine of 5 times 1 is a 5 minus a 5 over 1 minus 1. And we have the sine of 5 minus 5, which is a 0, over 1 minus 1, which is a 0. The sine of 0 is 0 over 0. We have the 0 over 0 indeterminate form coming from a trig function and a power function, so we're going to make use of the identity. Limit as theta goes to 0 of the sine of theta over theta equals to 1. What you have to do is match the other position with the phase of the sine function. Our sine function is in the numerator. I'm going to rewrite and isolate the sine function, which is in the numerator, away from the x minus 1, which is in the denominator, into a separate fraction. These are multiplying, equal to the original, so that I can match the other position with the phase of the sine function. Its phase is 5x minus 5. I'm going to put that in the denominator. To compensate, I'm going to put 1 in the numerator of the other fraction. We now have the limit as x goes to 1 of the sine of 5x minus 5 over 5x minus 5. There's the matched phase in the other position. The second fraction, I'm going to factor a 5 out, leaving us with an x minus 1. And the x minus 1's can cancel, and it will just be a 5. This first fraction is the perfect form with the matched phase, both of them going to 0, so it's going to equal to a 1. And we have a 1 times a 5, which is